Formula of an alkyne, C5H question mark, C3H question mark. How many hydrogens are going to be in each of these alkyne formulas? We can draw it, or we can do a little formula. Let's do both. Let's start with the drawing. C5H question mark. We're told it's an alkyne, a pentyne. Let's start with our 5 carbons. 1, 2, 3, 4, 5. Now I can put the triple bond anywhere. I'm going to put it in the middle right there. How many hydrogens are present in this generic formula? We need to remember that carbon bonds 4 times. So let's start finishing out the valence shell of each of these carbons. Let's start over here at the end, just at the left side. This carbon needs 3 more hydrogens. So H, H, H. This carbon here needs 2 more hydrogens. This carbon here, this carbon's already done. I've got to be careful about this. 1, 2, 3, 4. This carbon's already filled up, as is this carbon. 1, 2, 3, 4. And this carbon here at the end. So this is C5H8. I'm going to quickly draw. What if I put this triple bond in a different place? We would have got the same formula. Let's do that with a drawing. Whoops. Let's put it at the terminus. And let's do the same thing. This carbon here, I got 5 carbons. Hydrogen there is full. This guy's already full. This guy needs 2 more. This guy needs 2 more. This guy needs 3 more. C5, 1, 2, 3, 4, 5, H, 8. These have identical formulas, but they're not identical compounds. And I said there was a little math formula. Let me show that. The number of carbons, you can calculate the number of hydrogens based on the number of carbons. So we just have an N here to represent the number of carbons. So the number of carbons multiplied by 2 minus 2 gives you this formula here. So for example, in our example, N equals 5. So 2 times 5 equals 10, minus 2 equals 8. So C5H8. Let's do the same thing over here with a drawing. Let's build, I'm sorry, I have a model here to kind of build this. C5. So this is 5 carbons, and it has a triple bond that's over here. Now, what I want to really note about how this bent geometry is in this carbon here. I just drew this line because it was comfortable to draw 5 carbons in a row, but that is not the geometry, okay? And these 3 carbons here, they make a very rigid link in the chain. And note how this can turn and twist at the end here. And then this picture here with the triple bond at the end, look at how different that geometry is compared to kind of the straight line drawing I drew. Now, I don't have hydrogens on this model, just for kind of clarity, but showing the parent chain, triple bond at the end, very stiff, but look at all the rotation that can occur down the chain right there. Let's do the same setup for this C3H question mark. Let's start with the formula this time, because you're probably going to start with the formula, so let's just do that. C3H8. N equals 3. So 2 times 3 minus 2, 6 is going to be 4. So this is our prediction that there will be 4 hydrogens. Let's draw a picture of that. 1, 2, 3. And I got to put a triple bond in there. Now, it doesn't really matter which one I put it in because it's just a mirror image of it right there. Now I'm going to fill in my hydrogens. This carbon can take on uno. This carbon, 0. And this carbon here, trace. Each carbon is bonded 4 times. Please double check that. Making sure your carbons match the count and making sure your carbons bond 4 times are they're not meaningless skills. And here we have that compound with the triple bond. This checked out, the formula checked out, and here's a little model kit showing it right there. And note that if we put the triple bond on the other side, it'd be the same thing. This is really like a linear pipe right here. Thank you.